This video is just going to show two examples of the application of the Bayes theorem. Please watch the previous two videos that developed the Bayes theorem formula and then also expanded on it with an example. Data from the Bureau of Labor Statistics indicates that in a certain month, 33.5% of the labor force had a high school diploma or fewer years. Okay, so I'm going to start writing out probabilities as I do this. So I know, eventually this is going to come up that, that percentage can be written as a decimal, 0.335. So essentially they're saying probability of high school diploma, right? 0.335. All right. And then it does say or fewer. And then 26.3 had some college or an associate's. So I'll just say associates. So probability of A, all right, is 0.263. And then probability bachelor's or more. So we'll just say B. Okay, so probability of bachelor's is the 0.402. Okay, now we are going to need conditional probabilities in this formula as well too, which is where these are going to come from. Of those with a high school diploma or fewer, 7.6% were unemployed. So we have, basically that's saying probability unemployed given a high school diploma. So remember, of those with a high school diploma. In the intuitive sense for conditional probability, this letter, whatever's here, right, the number representing that letter goes in the denominator. So saying of those with a high school diploma. All right, so probability unemployed given high school, that is 0.076. And then it goes on to say of those with an associate's degree, 5.8 were unemployed. So probability unemployed given an associate's degree is 0.058. And then probability unemployed given bachelor's degree, so of those with a bachelor's degree or more, 4.7 were unemployed, so 0.047. I want to mention something here because sometimes this specific question, well, let me read how it says it first here. It says, find the probability that a randomly chosen labor force participant has a bachelor's degree or more given unemployed. So probability bachelor's given unemployed. All right, now sometimes they ask for probability bachelor's given employed. All right, so you'll need to figure out some of these other, especially the conditional probabilities, because these are all going to have to be employed. So I'm going to just mention that now. This one doesn't, but if you had to find probability employed given a high school, it's just 1 minus 0.076. So it's it is the complement. So that would be 0.924. All right, we're not going to need these ones in this particular problem, but sometimes you do. So probability employed given an associate's degree is 1 minus 0.058, which is 0.942. And then probability employed given bachelor's is 1 minus 0.047, which is 0.953. Right? So depending on how they ask the question, sometimes you actually need those probabilities versus the unemployed, but that's not the case here. Okay, so working out the Bayes theorem here. Probability of B given U is equal to the probability of B times the probability of U given B. So we're on the right track here with our conditional probabilities. And then we know we started with this. So probability of B times the probability of U given B plus. Now these unemployed can come from multiple categories. So we need the probability of unemployed and high school. Probability of unemployed and associates. So watch my other video how I develop that. All right. So now it'll be let's look at the high school. So we'll do probability of high school times the probability of unemployed given high school, and I'll do this one down here, plus probability of associates times the probability of unemployed given associates. Okay, now we have all those numbers, all right? So it is 0.402. I think I'm not going to put the zeros in anymore for the placeholders. So now we need times the probability of U given B, which is 0.047. Okay, so that we're multiplying there. The first one, I'm going to write a little smaller here, is just a duplicate of what was above. Now we're going to focus on the high school, 0.335 times unemployed given high school, 0.076. Now we're going to focus on the associates, 0.263 times, now that's the unemployed given associates, 0.058. Okay, so just enter this into a calculator. The numerator that we end up with in a calculator is 0.018894. You put all that in, and in the denominator we will get 0.059608. And then you enter that in a calculator, and you get 0.317. Okay, so we had to use Bayes' theorem for this one. There's no contingency tables to go from. And the unemployed come from different categories, right? High school, associates, and bachelors. So that's another key indication of Bayes' theorem. Let's look at another example here. Person applies for a certain job, and the probability that he or she is qualified is 0.433. All right, so I'm just going to call that Q. Probability qualified, 0.433. We may need unqualified, so I'm just going to put that now. So the probability the person's unqualified is 1 minus 0.433, and that is 0.567. So in case we need that. Okay, then it says the personnel manager claims that the probability that she approves a qualified person. All right, so that right there is probability approved, for A for approved, given the person is qualified, is 0.238. And then the probability approved given the person is unqualified is 0.305. Now what we need to find is probability that a person is qualified given the person was approved by the manager. All right, so people are approved whether they're qualified or unqualified apparently here. So there's our two different categories that we're going to use in our denominator, qualified and unqualified, and they're up here too. We know probability of qualified and probability of unqualified. So those are the two different categories that approval is associated with. So this is going to be written out as probability of Q times the probability of A given Q. All right, now typically the denominator is just the probability of A, right? Probability of approved. But probability of approved has to be taken into account that you can be approved and qualified, or you can be approved and unqualified. All right, so that's the whole emphasis. That's the whole point of the Bayes' theorem here, the denominator. So we're going to have, and I'm almost tempted to, and I have a little bit of time, I'm almost tempted to write it out a little bit more, but I don't think I will. Just look at my previous videos and how it's all expanded here. Probability of approved and qualified can be written, or qualified and approved can be written as probability of Q times the probability approved given Q. That's the probability that a person is qualified and approved. Or the person can be unqualified and approved. So it's probability unqualified times the probability approved given unqualified. Okay, we have all these probabilities. They're all up here. Okay, so it'll be 0.433 times 0.238. Now I'm just going and finding these numbers here. Remember, the first one that we write is usually a duplicate of what's above. But now we have those people who are unqualified and approved. So probably unqualified is 0.567, and then times the 0.305. Okay, in our numerator, you type that in a calculator, we get 0.103054. Our denominator, we get 0.275989. And then when you put this in a calculator, you actually get 0.373. And I've been keeping the answers here. They say 0.374. However, usually there's some rounding issues, or they had rounded it a certain way. Maybe they didn't use all the decimals here. But either of these answers would be fine. And that's an application of the Bayes theorem. So watch all 3 videos, and then you get a good sense. And I think this last example, actually, the way it's explained, the last example brings it back to the first video where I'm expanding out, right? So take a look at all these videos in totality, and you'll kind of see how this denominator works in the Bayes theorem.